The next lesson is talking about rational expressions. This is going to be something that's huge for you, excuse me, in subsequent years and in courses. Okay, rational expressions in grade 10, you guys, and even part of grade 9, you guys started to look at polynomials. Okay, and even in this course, the quadratic is a polynomial. But now rational expressions, some of you get a little nervous because we're saying, well, what are they? It's an algebraic fraction, and that alone is enough to scare some people, because we know that your skills with fractions are probably some of the most challenging things that you guys have issues with. So now we have fractions with the numerator and the denominator, basically the top and bottom, being polynomials. So now we have fractions with letters. Okay. So here's some examples, simple examples of rational expressions. 6 over x, rational expression. This guy is also a rational expression. X plus 3 over x minus 4. And then you can see we're getting more and more complex as we're showing these examples. Here's another one, 2x minus 5 over 2x squared minus 3x plus 10. So all of these are rational expressions, getting more and more complex as we go along, but they're just fractions. So all the rules of fractions still apply. To multiply two rational expressions, we multiply just like fractions. To divide, we divide just like fractions. Flip one of them and multiply. To add, we need or subtract, we need a common denominator. Common denominators now aren't numbers. They're polynomial expressions. So you have to know a lot of stuff about polynomials and basically how fractions operate. But before we get too much into a lot of that, we're going to just test a little bit of knowledge here. This goes back to even elementary school. You guys take something, they call it pre-algebra, but then you do a lot of this in junior high. Evaluate the following when x equals 3. So this shouldn't be challenging, okay? But what it will be is a review. So A, if I said 6 over x, polynomial expression, because I have a rational expression, I have a polynomial in the numerator, a polynomial in the denominator. How would we solve this? Yeah, it's just simply 6 over 3, which is 2. Not challenging. So let's look at a different one. B, x plus 3 over, Lachlan's suggesting that there might be a curveball somewhere. Would we ever do that to you guys? Always. Okay, x plus 3 over x minus 4. If I needed to evaluate this when x equals 3, well, it's just put a 3 in for x, put a 3 in for x. So it's 6 over negative 1. We'd simplify this. What is that? Negative 6. Tough? Good. Now, Lachlan keeps talking about curveballs. So.
It always just makes sense for that first one and flat.
Okay. Here's your first sort of curveball. I think the first step nobody will have any issues with. They're like, that's easy. I'm just putting a 3 in. Everybody okay with this? Like substituting, nothing wrong with what I've done yet. I'm trying to evaluate it when x is 3. What are we running into? Sam's suggesting it. What else is it? I'm getting negative 4 over 0. I heard some people say that's 0. And some people think this is negative 4. But, what did you say? This is undefined. Why? The first commandment of math. Thou shalt not shall not divide by 0. You cannot do it. Nothing is divisible by 0. If you think of what dividing means, if I said 6 divided by 3 in that first example, we're saying take 6 things, divide them into 3 groups. How many groups do we have? 2. This guy says let's just assume it was a positive. Let's take 4 things, divide it into groups of nothing. Can you do that? No, you still got 4 things there. And then there'll be the smart guy who goes, easy, I just ate them. And you're like, well, now you've done subtraction, not division. No, dang. Okay, so you cannot divide by 0. Easy? Yep. You'd write undefined. You can write this. Okay? Lachlan will do it once, and then he'll realize this is fewer letters, and he'll never write this again. Because he's all about the efficiency. Okay, so here's what a big topic in math. And we talked about it with radicals. We talked about restrictions with radicals, right? That radicand had to be greater than or equal to 0. We're now going to talk about restrictions with rational expressions, but these are also called non-permissible values. Now, you know math people inherently are lazy. We'd say the word non-permissible value. It's not hard to say, but we talk about it as your NPVs, non-permissible values. Okay, so restrictions, we talked about restrictions on radicals. Now we're going to look at restrictions on rationals. So we're going to start with somewhat of a definition here. What is a restriction? Any value of the variable that would make the denominator of a rational, let's abbreviate it, rational expression zero. So the last example, we saw that we had 3 minus 3 on the bottom, which was 0. That can't happen. So we have to be able to look at rational expressions and say, when can things not happen? Basically, when are things dividing by 0? Anybody scared yet? Okay. Did you hear the concern in my voice? Okay. Determine the NPVs, or determine the restrictions. It doesn't matter how they ask the question. They could say determine the non-permissible values, determine the restrictions, determine the values for which x make the expression undefined. They're all talking about the exact same thing. So determine these. We're going to look at some examples. So first guy, a, 4a over 3bc. Pardon me? No. No. Okay? Jake's question was, am I telling you what the variables equal? No, I'm not trying to get you to evaluate this expression. The variables could be anything, but what we're trying to determine are, if the variables can be anything, what can't they be? Because certain things will make this divisible by 0. So if I'm looking at this, does it ever matter the value of a? No, because it's on the top, and the top can be 0. The values here that would make this bottom 0 is if b is a certain value or c is a certain value. What values would those be? B can't be 0. There's one restriction, because if it is, I have 3 times 0 times c. Anything times 0 is 0. The other thing, c can't be 0, because I'd have 3 times b times 0, and again, anything times 0 is it. That's your restrictions. That's it there. So far. So B, this is the biggest mistake kids make though. Okay, the restrictions have something to do with the denominator being 0. The biggest mistake is that you assume that it always is 0, or that you identify its other numbers, but it also has to include 0. It doesn't. And we're going to look at different examples as we go along. So here's another one. X minus 1 over x times x plus 2 times x minus 3. So here's the next example. X could be anything we want, except there's certain things it can't be, because then the bottom or the denominator will be 0. Then we're dividing by 0. How do you think we tackle this? Add them all up? Well, we can't add them. It's multiplying. Okay, so Brandon's suggesting here, he's saying, if I put a 3 in for this x, the last one here, 3 minus 3 gets me 0. So this would be a 3, because if I put in an x, I'd have 3 times 3 plus 2 is 5. 3 times 5 times 0, the whole bottom is 0. Oh, no. Can't be 0. So the easiest thing to do, take our three things. Say, well, if this equals 0, the whole bottom's going to equal 0, because I'm multiplying by 0. If this thing, x plus 2, equals 0, the whole thing would equal 0, because I'd have x out front times the thing in the back, and that middle term, 0, wouldn't work. So this is saying, if x is negative 2, that middle thing on the bottom is 0, then the whole bottom would be 0. This guy here, and Brandon suggested x minus 3, if that thing equals 0, and solve for x, yeah, x equals 3. How many restrictions do I have? Just 3. Now, I see some eyes out there going, it's not clicking, like, say, negative 2. Is that right? If I put a negative 2 in the bottom of this, let's just take a look. So here's this. If I put a negative 2 anywhere, I guess. So I'm saying negative 2 minus 1 on the top. Then I'd have negative 2 plus 2, negative 2 minus 3. So if I look at it, the top becomes negative 3. The bottom is negative 2 times 0 times negative 5. What does that whole denominator equal? 0. So I get negative 3 over 0. That's undefined. So it doesn't matter. Each one of these non-permissible values we identified, if I put them in, somehow the bottom will equal 0. I can't divide by 0. Make a little bit more sense? Okay. Brandon? Zero is not always a default. Unless you're multiplying just by an x. So maybe we'll look, I'm going to see if my examples, yeah, let's look at the next guy. This will kind of clear up what you're saying, I think. Okay? So let's look at, I don't know, how are we naming these? ABC, right? Here's C. Let's say 6x squared minus 4 all over 2x minus 3. So on the bottom now, I only have one thing, 2x minus 3. Do I ever care if the numerator, the top part, is 0? Never. It's the bottom that I worry about. So basically we're saying I can't have this bottom, the 2x minus 3 is not allowed to equal 0. How do I start solving for x? Add 3. So 2x can't be 3. Divide by 2. X is not allowed to be 3 halves. There is my restriction. Is 0 a restriction at all here? Is 0 a restriction? No, because if I put a 0 in the bottom, 2 times 0 is 0 minus 3. The bottom's negative 3. That doesn't matter. Okay? Is it really tough? No, so let's take a step, because Lachlan always says, you know what, I hate it when it's easy. Give me something a little bit more challenging, Sabai. So let's look at this guy. Here's the next little example then, and it is little. I don't care what the top is. I never care if the top is 0, because I'm allowed to have 0 things and break it into 6 groups. Each group would just have 0 things in it. But this one, I have to figure out what's going to make this bottom 0. There's 2 ways to do it. One is just trial and error, like just start picking some values for p and hope it equals 0. That would suck. It could be done, but it would take a while. What's another way to do it? I could solve it, but really, wouldn't it be nicer if it looked more like this one? If I had factors, I never knew so many people just hated math. Factor the bottom. This is an easy factoring one. So remember, we keep hammering factoring. Why? Because you need it all of the time. So let's factor the bottom. I need to factor p squared minus p minus 12. Different people factor in different methods. However you factor it, you should be able to determine that this simply is p minus 4 and p plus 3. Those are my factors. So if I rewrote this expression that I have in green, I have 2p minus 1 over p minus 4, p plus 3. Is it easier now to see what would make your bottom equal 0? Yeah, I'd say, well, p minus 4 is not allowed to equal 0, so p can't be 4. And here, p plus 3 is not allowed to equal 0, so p is negative 3. I have two restrictions, two non-permissible values, two values for p that would make this expression undefined, however we want to say that to you. There. Is 0 a restriction now? No, but some people always think that they have to include, and it's frustrating to mark those. People will get this part right, and then for some reason they go, yeah, but it still is not allowed to equal 0. It can equal 0 here. We just get a different number, not 0. So this is not an option. Jake? There can... Sure, if we had a whole bunch, yeah. And in grade 12, like right now, you guys are only responsible for factoring things that are squared. In grade 12, you have to factor things that have an exponent of 5. So 5, exponent of 4, 3, 2, or 1. So you have to factor something that has a power of 5 on it. Okay? Here, raise the roof. Here's the last one that I'm going to let you sort of try. 2y squared over y squared minus 25. I'm not going to give you too much direction on this one, but I want you to see if you can try to solve. All right, now we had some time to look at it. Some people told me their answers, and they're correct. But how do we get this? Down here, we should probably somehow factor this. It's not a perfect square, but you got the terms sort of right. What is it? It's a difference of squares. So it's y minus 5, y plus 5. So all these little things in factoring that you learned in grade 10 are crucial to do anything like this. And remember, this is just the beginning of this whole non-permissible value. This is a beginning step. This is going to be something you're going to have to do with every question, even though we're multiplying or dividing or adding or subtracting. So now, and I would probably think most of you should be able to look at this and think, on this one here, what's going to make that equal to 0? Negative 5. So y can't be negative 5. This guy? Y can't be 5. A true math person probably wouldn't write it like that. They'd probably say this, y is not allowed to equal positive or negative 5. And it doesn't matter which way you write it, but that's the way you'd see it given in textbooks or anything like that, because it's just more condensed. Both methods are right. This one in the box is just a little bit clearer.